Everybody, happy snow day. We are going to be looking at lesson 8 today. It's nothing new. It's some more trigonometry. So there is no quiz happening, but we are still going to look at lesson 8. You can check this video at any time to see these 10 questions in play. All right, on Monday, if we are at home, you're asked to work on your selfie assignment. Send me a picture of what you have so far on Monday. I'm looking for a picture to send via email or on Teams chat or in the OneNote, so you can send it in the OneNote. Everyone has like a folder here, and you can send it in the OneNote under class notes. So any of those places, that's where I'm going to be looking for a picture of your selfie assignment on Monday. Tuesday, we'll have a review. Hopefully we're back in school. And then Wednesday is still our test on November 23rd. Right? And our selfie assignment is due December 1st. So again, I want to see on Monday a picture of what you have so far. And let's go. Let's check out lesson 8. So as you can see here, I've starred a couple of the more challenging ones. So if you wanted to skip ahead on the video and check those out, you're more than welcome to. But I'm going to go through each and every one individually. All right, so the first step is to write out our left side and right side. So the left side, or LS, of our first one, we can see it's secant theta minus tan theta sine theta. And then on the right side, our RS, we have 1 over secant theta. All right, so here, one of the tips is to always change everything to have sine and cos. Okay, so our secant theta, we should know these. Unfortunately, we're not going to be having these formulas on the test. The only formulas you'll have are the sine law and cosine law, but we know them all. We know all these formulas already. We know that secant theta is the inverse of 1 over, and then it's not sine, right? It's the opposite, cosine. So let's go fill that in. So this is 1 over cosine theta minus tan. Well, instead of writing tan, we should know this formula to be tan theta is equal to, it's always sunny, right? In order to get a tan, so sine's on top, cos is on the bottom. So we have sine theta divided by cos theta, and then this is times sine theta. Okay, so let's keep on going here on this left-hand side. We can see that we have common denominators. Also, what are we going to have on top? So the common denominators can come together. That's cos theta. And on top we have 1 minus sine. Well, sine times sine is sine squared theta. And we should know this formula, 1 minus sine squared theta. That is a part of our Pythagorean identity. So that's cos squared theta plus sine squared theta is equal to 1. Or it could be like sine squared theta plus cosine theta. It doesn't matter where these two are placed within the formula. But we can see here, if we move the sine squared theta over to the other side, we get cos squared theta is equal to 1 minus sine squared theta. So anytime we see a 1 minus sine squared theta, we can write cos squared theta. Right, so let's go put that on top. So cos squared theta divided by cos theta. Well, and if we have 2, this is almost like x squared, right? Divided by x, or 2 x, or 2 coses and 1 cos. If we have 2 coses and 1 cos, those 2 cancel out to just give us 1 cos left over. And hey, that looks like the inverse of cos theta. And there we go. Left side is equal to right side. Quadratura demonstratum. Perfect. Let's go check out question 2. All right, for this next question, we have 1 plus cos theta divided by sine theta. And then over here we have cosecant plus cotangent theta. Well, there's nothing we can really change here except like we could put them both underneath sine theta. So they can both be written underneath sine theta. This is 1 over sine theta plus cos theta over sine theta. Just like the opposite here, right? We wrote them, these two underneath 1 cos. We can write these 2 terms on top both underneath sine. Let's go check over here. Cosecant, well, that's inverse of 1 over It's not cos, right? C and C don't go together. This is sine theta. And then we have plus cot theta, cotangent. And cotangent is the reciprocal of tan. And tan we know is sine over cos. So this one's cos theta divided by sine theta. Hey, look at that. They're both equal. So left side is equal to right side. All right, for this next one, we have our left side and our right side. Let's go ahead and look at the more challenging side first. That looks like our left side. A little bit more space. All right, so secant we know is 1 over cos theta. And this is going to be multiplied by sine theta. And sine theta is over 1. Or you can write sine theta on top. And then tan theta is the same as sine theta divided by cos theta. And then cotangent is the opposite, cos theta divided by sine theta. All right, and then here what we're going to do is we're going to, well, something's being added in their two fractions. If we kind of try to simplify the top, and then we'll try to simplify the bottom. So here we get sine theta divided by cos theta. That's on the numerator, right? 1 times sine theta is sine theta, 1 times cos theta is cos theta. Then we have this line, and then we're going to try to simplify this denominator. Well, the denominator has two different, right, terms on the bottom, so we're going to look to see if we can find a common denominator. So to find a common denominator, we're going to multiply this by cos theta divided by cos theta, because we don't have a cos theta over here on the denominator. And this one by sine theta divided by sine theta, because again, we don't have a sine theta here. So now they both have a common denominator, so we can write the common denominator underneath. That's both sine times cos theta, and on top we have sine squared theta plus cos squared theta. Does that look familiar? I hope so. This is sine theta over cos theta, that's our numerator, all divided by 1 over sine theta times cos theta. This is the same thing as saying sine theta divided by cos theta times, right? If these two are being divided, we're going to multiply by the reciprocal. So sine theta cos theta divided by 1. What happens here is those two cos thetas cancel out and we get sine squared theta. Is that what we have on the right hand side? Yes, that's it. Left side equals right side. Okay, for this next one, again, we can't really work with one. You can change it to the Pythagorean identity, but hopefully we get that over here in some way. All right, let's go ahead and change secant. So secant's 1 over cos theta. This is divided by cos theta. And then this is on the numerator, so it's still on the numerator, and then this is on the denominator. Minus tan. Tan is sine theta divided by cos theta. Again, that's on the numerator. That's a fraction on the numerator divided by, and then we've got on the denominator cos theta divided by sine theta. And that is on the denominator. All right, so let's look at each of these separately and try to simplify them. Well, when this gets divided, we're going to flip it. All right, 1 over cos is going to be multiplied by 1 over cos. So we're going to get 1 over cos squared theta. How'd that happen? 1 over cos theta divided by cos theta divided by 1. We need to switch it and multiply. So that's 1 over cos theta times 1 over cos theta. So we get 1 over cos squared theta minus, and then again, this is going to flip, the sign is going to come up with this sign, and the cos is going to go with this cos. So we're going to get sine squared theta divided by cos squared theta. Right, it looks like they have common denominators, so let's put them all underneath one denominator. And we have 1 minus sine squared theta. Right, it's not looking like the Pythagorean identity, so that wouldn't have been a good idea to do over here, but it is looking like something to give us 1. Right, that 1 minus sine squared theta, we've written that before. That was way up here. here, 1 minus sine squared theta is cos squared theta, right? So we have cos squared theta divided by cos squared theta, and that is equal to 1. Left side equals right side. And just a reminder that anytime you can pause or rewind or fast forward these videos, right? So we're looking at this one. Really watch out for this. This is not a Pythagorean identity. The Pythagorean identity has to have a plus sign, like a squared plus b squared equals c squared. So it has to have a plus. So this is not equal to 1. Over here, let's go check this out. So we have something with a 2 here, right? And that 1. We saw something like this in class the other day. So it would be a good idea here to see if we can change something like this 1. We can change that 1. That 1 is cos squared theta plus sine squared theta, the Pythagorean identity. And then this would be minus our 2 sine squared theta. It's minus whatever is left over. So that 1 right here is the Pythagorean identity. So that's that. Is there anything here that we can put together? Yeah, these two signs. So we have cos squared theta, and what's 1 minus 2 is negative 1. There we are. Left side is equal to right side. Right, for question 6. Again, let's go ahead and look at the more challenging one and change it all to sines and coses. So here we have CSC squared theta. That's the same thing as 1 over sine squared theta. And then tan squared theta is the same thing as sine squared theta over cos squared theta. So it still is the exact same identities, just this case we have squares. Minus 1. All right. Is there anything that can cancel out here? Yeah, those two can cancel out. So we're left with 1 over cos squared theta minus 1. So if we did change this to the Pythagorean identity, it's not really giving us any like helpful things. Why don't we do common denominators? 1 over cos squared theta minus, this would be cos squared theta divided by cos squared theta. All right. So because you'd multiply this by cos squared theta and divided by cos squared theta gives us this, right? On top we have 1 minus cos squared theta divided by cos squared theta. And what is 1 minus cos squared theta? Well, that's sine squared theta divided by cos squared theta. And this one is tan squared theta. Left side is equal to right side. All right, this is going to be the last one on this video, and then I'll make a video for the rest. Okay, so here we saw something like this in class yesterday as well. If we have something squared, that means we have to FOIL it, right? We have to write it out twice. Same with this one, we have to write it out twice. So this would be sine theta plus cos theta times sine theta plus cos theta plus sine theta minus cos theta, and then sine theta minus cos theta, right? And then we're going to FOIL, because there's nothing we can do here. The square does not come in just on the sine and the cos. You will be missing that middle term, right? Sine squared theta, and then we get a 2 sine theta cos theta plus cos squared theta plus sine gives us sine squared theta. Sine and negative cos is negative cos theta. Subtract another cos sine, so we get negative 2 cos theta sine theta, and then plus another cos squared theta. All right, let's see if we can organize some things here. Those middle terms here and here, well, they cancel out. And then we have a sine and a cos. Sine squared plus cos squared. We know what that is. And then we have another sine squared plus cos squared. Well, this equals to 1 plus 1, which is 2. Left side is equal to right side.